A particle moves in a straight line so that the displacement at any time is given by x square is equal to 1 plus t square. We've been asked to find out the acceleration. So differentiating with respect to t, mind you, with respect to t, what we have is d by dt of x square is equal to d by dt of 1 plus d by dt of t square. Of 1, we know this is 0, right? For t square, it is 2t. And for d by dt of x square, it is d by dt of x square into dx by dt. And what is d by dt of x square? It is 2x. So we have 2x. Okay, so let me just try to explain this a bit further. So it goes like this. So if we have d by dx of, okay, y square, what will this be equal to? 2y into dy by dx. Same logic here. Okay. Now, dx by dt we know is velocity. So we have 2x into dx by dt as 2x into v is equal to 2t. 2 upon 2 is 1. So we have x into v is equal to t. Now we'll differentiate this equation further with respect to t. Therefore, x into dv by dt plus v into dx by dt. How? Come on, this would be UV rule, right? dv by dt is acceleration, dx by dt is velocity. So v into dx by dt becomes v square. X into a plus v square is equal to 1, and therefore a is equal to 1 minus v square by x. Now, we already found out that xv is equal to t. Right? We just wrote this sometime before that xv is equal to t. Now what we'll do is we'll substitute this xv is equal to t in this fraction over here. So what is v from here? So we can write here v is equal to t upon x, right, from this equation. And then we'll substitute this v as t upon x over the numerator. So we have 1 minus t by x the whole square, which will be equal to 1 minus t square by x square. I have taken this to be the fraction here. So what can I write it further? Let's say that x square minus t square upon x square, the whole upon x. Now, what is x square minus t square upon x square? See, what is x square minus t square? We know that it is given the question that x square is equal to 1 plus t square, x square is equal to 1 plus t square. So, what will be x square minus t square? It will be equal to 1, which means this numerator here would be equal to 1. And then all what is left is 1 upon x square the whole upon x, which will be equal to 1 upon x cube, right? So we have 1 upon x cube, or which is equal to x to the power minus 3. And what is asked in the question? It is given the question that acceleration is equal to x to the power minus n. Acceleration is equal to x to the power minus n. Therefore, n is equal to, while comparing these two equations, we have n is equal to 3. Yes, there is a probability, possibility that you may make a mistake. In fact, I did the first time while I was solving this question that I wrote this as minus 3. And being an integer type question, these kind of, mistakes, although they are silly, they do, occur a lot while we solve questions of integer type that to happen. Okay, anyway, that comes to practice. And even if you have a lot of practice, there is some possibility that you'll make an error. So, revisiting these questions will help you overcome that. Okay, so that's this question. I think almost a major chunk of the questions here is based on application of differentiation or integration.